Hey, hi, hello guys, welcome back to Code with Nani channel. So today the lead code problem of the day 38, which is count and say. So the count and say sequence is a sequence of digit strings defined by the recursive formula. So here they are given a starting string count and say of 1 is 1. So we need to return the count and say of n is the run length encoding of count and say of n minus 1. So what is this count and say this recursive run length encoding and all? In a shorter words, suppose if you had a string like this, so you can say if you had a string like this, okay, so how many threes are repeated here? Two threes has been repeated. Okay, how many twos has been repeated? Three twos has been repeated. How many fives? One five has been repeated, right? And how many one? One has been repeated. Okay, so we need to append the same string. So two threes, two threes has been repeated. Three twos has been repeated. Three twos. One five has been repeated, and one one. So we need to return the string in this format, which is RLE, run length encoding. So that's what they mean. What is that run length encoding? So if you come to this question, so what they are giving you, so what they will give you as this n value, we need to return the length of the we need to return the string of length n which has this run length encoding. Okay, so how it goes, I'll let you know. As they already mentioned, always the first string starts with a 1. Okay, so let's just take n equal to 1 case. Okay, always the string starts with 1. And for the n equal to 2th case, for n equal to 2th case, the string will becomes as the input for the n equal to 2. So how many ones we have? Only one, right? So that we will do 1. For the n equal to 3rd case, so we have a string 1. So we have a two ones repeated, right? So use the same formula that we did before. What is that regarding RLE? So two ones has been repeated, so that we need to return. So for n equal to 4th case, this will become an input for the n equal to 4. So if we take this as an input, 2 1 we have 1 2 1 1, because we only have a 1 2 1 1. So that we need to return 1 2, because string of 2 has been repeated only once. 1 1, which is string of 1 has been repeated only once. So we need to return the string that consists of length 4, which has the run length encoding. So that is the answer. See, so what is the intuition of this problem? As the constraints is very low and is less than or equal to 30, so you can go for the recursion. So suppose if you go through the recursive solution, the time complexity of this solution becomes 2 power n, so which is well and good. And space complexity will becomes O of 2 power n, that is okay, plus n. Why this n? Because it needs to store all the recursive calls in a stack space, which additionally leads to the of n space complexity. Okay, so that's why the space complexity will becomes 2 power n plus n. So if you write the same recursive solution in a linear fashion or in a normal iterative way, that will leads us the same time complexity, which is of 2 power n. But we can optimize the space complexity. The space complexity will becomes 2 power n. So that we will discuss in this video. Okay, as recursive approach, just for each string length of n, we will iterate through this string length and we'll find it. So I'm not going to discuss the recursive solution, because if you know the iterative solution, we'll write the same thing in a recursive solution just by replacing the and by just calling the same function again and over again. But here what we do, we'll go in an iterative way. Instead of the iteration of for loop, we'll simply call the recursive function. That is the only difference between the recursive solution and the iterative solution. So let's just jump into the iterative solution. Okay. So, so as far we know, the starting for the base case, that will be n. So until what we need to find out, we need to find out the length of the nth string. We need to figure out the string of n length, right? So definitely I have to iterate from I equal to 1 to I less than n I plus plus, because right now we are in the string length 1, so that's what I'm not concerned about the 0, because we already took that case. Okay, so for each for each for each length, what we need to figure out, suppose as suppose we are in an equal to third case, okay, which is 2 1. So what we need to figure out is, we need to check how many times the current element has been repeated. The current element has been repeated once. So what we need to do, we will take a temporary string plus equal to count, to string of count. So as the count is 1, that will append 1, and temp plus equal to the character. What is the character? That is the current character. So that will append 2. Okay. So 1 2 has been done. And for the last one, we'll do the same thing. The count is 1 and the string is 1. So that's how we will obtain a new string of that particular length. Now for the next iteration, we'll check how many times 1 has been repeated once. So that's how we go. Okay. Now we'll get clarity. So what we can do is, we'll maintain count as 1 as the initialization, and the current character is equal to whatever be the string of 0. Now we'll start from 1 to n. Okay, 1 to s dot length I plus plus. What we will do is, we will check until, so if s of I equal to character, which means if the current character is equal to the previous character that we are comparing, so if it is same, just increment the count. Else, if they are not same, so if they are not same, what we can do, just simply append this to a some temporary string. Temp plus equal to, what we need to append first, the count, to string of count. Okay, then what we need to append, the current character. Now what will happen is, the count of this frequent, as the current character and the previous characters are not same, we will make current count as 1, and the current character is equal to the s of I. That's it. We keep on doing until we find the nth run length encoding, then we finally return it. So I'll just jump into the coding part. You'll get clarity around this. So see here see here now I'm just initializing the string s with 1, because as we know, for the base case, string always will starts with 1. Okay, so from I equal to 1 to less than n, because we already initialized count of string with 1, so we need to iterate to the n minus 1 times. So that's what I'm doing, 1 to n minus 1 times. So I'm just for each iteration until we get to the nth point, we are just maintaining a temporary vector, as I temporary string, as I told you. So which we will do operation, and finally we'll give it to the s as well. And the current count will be 1. And what is the current character? Let's just take s of 0 as the current character. So I'll iterate through that string. Okay, If the current character and the previous character are equal, just increment it. Else, what I told you, else we'll just append this count of this character to the temp and append the character as well. Okay. Then what you'll do? Initialize, reinitialize the count as 1 and the current as the current character. Okay. So after all the operations are done, why I'm appending again? Because because so what I'm doing, so suppose if there are 1 2 3 1 1, okay, and until this part it is done. Now as these two are different, the current count will become 1 and for this iteration, okay, and the current character will also becomes 1. So if you see in the else part, okay, so then in the next iteration it will check as s of I and the current are equal. Now the count becomes 2, okay, and the string ends. But we never added these things to this temporary vector, right? Because when the current character and count will be added whenever current character is not equal to s of I, right? Because as it is ended, the string is ended, but still the count is 2 and the current character is 1 and it is not been appended to the temporary variable. So for that check, so after all the iteration, we are not appending the current characters and the current count to the temporary variable when it is at the end of the string. Okay, so for that thing, see, appending that last group. So for that case, we are re-appending the after the current loop. So we are appending after the loop. Okay, temporary plus to string of count, which is the last group count and the last character. So after everything is done, simply uh, you know make this temp into the push this temp into the s, because for this I equal to, suppose let's just take I, now the I is 3. For I is 3, we got a string which is temp, so we need to give that to the s, right? Now s becomes the temp. And finally, after all the iteration, we what value that s stores is the nth string of a RLA. Okay, finally we'll return answer. So, and that's it for today video, guys. So if you like my explanation, do like the video, subscribe to my channel and hit that bell icon so you never miss any notification from my channel. And if you have any queries regarding my code or regarding my explanation, do put it in the comment section. I will help you guys. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow with a great content. Bye bye.